and whether he's tenured or not, that data is already given to you. Now what I do is I take that particular thing, I apply a classification algorithm. The algorithm could be a decision tree, the algorithm could be a KNN algorithm or a naive Bayes, depending upon the kind of data set or the kind of data I'm dealing, I choose the algorithm. So once I take that, I build a model. Now, if you can see, using the classification algorithm, a model has been built. And what is the model saying? The model is saying if the rank is professor, or if the number of years he is experience is greater than 6, then either of the condition is true, I mean, is there, then you can simply say that he is tenured, he or she is tenured. Now, suppose if I have an unknown person, and I just tell his rank, and I tell the, or either a rank I give or the number of years of experience I give, I can make out whether he's tenured or not. Okay, so this is how your model will be useful in predicting the class label for an unknown data sample. So the first step here is your model construction. I am trying to construct the model. And the second step, as you're seeing, I am trying to go for a test data. For the test data, already the class labels are known. I already have an idea about the class labels. So having known the class labels, I can easily predict the accuracy. Now, suppose in this case, I have four persons data with me. I just do not give the tenure data. Already you have your model that has come up here. So I just try to give my model, like suppose the first case for Tom, he's an assistant professor and the number of years of experience is 2. So here I say none of the conditions is satisfying. It is either or condition. So rank is professor, that is false. Years of experience is 2, that is also false. So both the conditions are false. So definitely tenured is no. So my model here, whatever rules it has brought in, it is satisfying your first triple. So the first data set has passed the test. Now look at the second one, Marilisa. He's is associate professor, so the first condition is gone here. But the number of years tenured is 6. But here, or years greater than 6, 7 is greater than 6. So you should say tenured is S, but my tenured here is saying no. So in this case, my test sample, my unseen data or your test data has not gone past the test. So the accuracy has come down little in this case. Now, if you look at the next two cases, George, professor, there itself, the tenure is yes. So your test case has passed. I mean, your model is satisfying your test case. If you look at Joseph, the number of years is greater than 6. That is also satisfying your test case. So out of the 4 cases, only 1 case failed and 3 cases passed. So I think 3 by 4 is the accuracy that you have. So now it is up to you how much accuracy with which you want to build, accept the model, that you have to decide. Now, if you have decided that this is a good model, then for any unseen data, I can easily predict whether he's tenured or not. Now, this is the first algorithm that I'll be going with, KNN, which is called as K nearest neighbors algorithm. K nearest neighbor algorithm is a non-parametric method. It doesn't have any underlying assumptions about this, unlike your logistic regression, which depends on certain sort of parameters. It is a lazy learning algorithm. It will just wait until the final computation is done. It will keep on taking the data, but it will not start building your model immediately. And this is also called as your instance-based learning algorithm. Now, when is this particular algorithm very useful? Your dimensionality, see, here there are two things that you need to look at. One is, here I'm saying when there are non-linear boundaries between the classes. If you look at SVM, support vector machines, they do a good job with your linear machines. Linear is something on a plane where I'm able to divide the data, the tuples belonging to different data sets very clearly, you passing, drawing a line or a plane between these particular data sets. If you are able to clearly, differentiate, drawing a line, that would come under your linear classification. Non-linear classification is where I'm not able to clearly draw a plane. So your data is totally scattered along with their class labels. Another thing where your KNN algorithm will be useful is where the amount of data is large. Here your dimensionalities should not be large. The number of dimensions or the number of features that are involved in your data should be less. And then but still the data is large, that is acceptable for KNN algorithm. Input could be both qualitative and quantitative type, but generally the outputs are your categorical values that you get. And how do I decide upon the output of your KNN? Here you go with the concept of majority voting of the nearest neighbors. I try to choose the nearest neighbors based on your majority voting. Now, what is the important parameter here is your K. So, your K and the distance matrix that you are using. When I am trying to choose the nearest neighbors, how do I look at the distance? I mean, how do I identify my neighbors? My neighbors are the ones which are close to me. So, somebody who's in the next line or after two lines will not be definitely my neighbor. My immediate neighbors are the most important ones which we look at. So, how do I bring out the neighbors? Here I go for what is called as some sort of distance metrics to calculate between the given sample and the very nearby points. For that, I try to go with some sort of distances, and the distances could be a Euclidean distance, which is square root of which you all might have learned in your with your line perspective, x1 minus x2 whole square plus y1 minus y2 whole square, or a Manhattan distance, which is absolute difference value x1 minus absolute difference value of x1 minus x2 plus y1 minus y2. And the other one you have is Hamming distance. Hamming distances are used with your Boolean values. The number of Boolean values are differing. So that is how you calculate your Hamming distance. So any of these distances metrics I can make use of. Here is when you look at KNN, finding the nearest neighbors and identifying the value of K. How many nearest neighbors? K is the number of nearest neighbors that you are looking at. So these are the two parameters which play a crucial role. This is one example which I would like to show you. Now, if you look at here, I have George, Rachel, Steve, Tom, Annie. This data is already given to me, whose age, income, and the credit cards is given. So I am supposed to classify into some label yes or no, whether I should issue something or not. Maybe that could be thing. So here, what do? I will try to find out the now I want to classify John, so I need to build a model, right? So if I need to build a model, KNN, as I told you, it's an instance-based learning. It's a lazy evaluation thing. It will not build a model and keep things ready. So what it does is, at that particular instance, when I have John here, it will directly try to calculate with the other values that are there in your data set. So I try to take the distance of John from George, Rachel, Steve, Tom, and Annie. What kind of distance measure am I using here? Here I am trying to make use of Euclidean distance, if you see. So when I am using Euclidean distance, I try to segregate. I mean, when I try to take from for John and George. So 35 square root of 35 minus 37 whole square. That is your age plus your income 50 minus 35 whole square plus the number of credit cards 2 minus 3 whole square or 3 minus 2 whole square. That is giving me a value of 15.16. Likewise, now again I try to take John and then I try to find his, I mean, here when I'm taking the distance, when I'm trying to calculate the Euclidean distance, I'm actually trying to identify who are the nearest neighbors to John. Okay, and then that is identifying your nearest neighbors. Then how many nearest neighbors should I consider? That is your K value. Okay, so now I'm just calculating John with George on the similar ground, John with Rachel, John with Steve, and I take 37 minus 63 whole square, 200 minus 50 whole square, 1 minus 2 whole square, square root of all these things. In the same way, John with Annie, I'm trying to do this one. So now uh, when you are whenever I mean once I calculate all the distance of John with all the other data points that I have or the tuple samples that I have in my database, I can see the values I'm getting is 15.16, 15, not 52. So first let us if suppose I assume that I will go with three nearest neighbors. So who are the three nearest neighbors to this John? So the least of all is Rachel, and the second after Rachel, I have George, that is 15.16. I mean, a neighbor is a one who with a very less distance, right? So 15.16. And then next comes the next one, which is very whose close is Annie, which is 15.74. Now, having decided the nearest neighbors, and I know how many neighbors to consider, which is K, that is three neighbors. Now, my next thing is, how do I classify the label? To which particular class does John belong? How do I classify that? For me to do that, what I do is I go with a majority voting. So in my majority voting, now I look at the three neighbors that I have. The three neighbors I have is John, Rachel, and George, Rachel, and Annie. Wherein George is having a class label of no, Rachel and Annie are having a class label of yes. So if I look at the majority voting, out of three, two of them are yes and one is no. So when two of them are yes and one is no, the majority voting says yes because the number of yes is more than no. So I decide the class label for your John to be yes. Okay. So the class label is decided based on your majority voting this way. Now, if I look at the k nearest neighbor algorithm, how do I mean, the algorithm which you have written in the word, whatever we have done here, I've written it in the word format. It is just performed using your four steps. Where first you try to compute the distance matrix between whatever is your test point that you are comparing with the all the labeled data points which are already available. So when I'm trying to that distance metrics could be Euclidean, Manhattan, any one of the distance metrics I'll try to use, and I'll try to find the distance this. Then the next thing is you're trying to order the label data points either in the increasing order of the, I do it in the ascending order, obviously, because I want to find the nearest neighbors. Then what you need to choose upon a K and select the top K labeled points which are very close to the distance metrics that I need to choose. After finding the class labels, after finding the nearest neighbors, I look at the class label of all these three neighbors whom I have already chosen. Whomsoever, based on the voting, majority voting, I try to classify the data point based on among the k nearest neighbors whose majority voting for which particular label is high. He will be categorized into he or she, or that particular test data will be classified into that particular class label. Now here is one diagrammatic view which you can see. Now if you can see, I have two red samples and one blue sample. I have one yellow test data that has come up. If I look at this within that particular vicinity or within that particular nearby samples that I considered, if I have taken three nearest samples, I can see that I have two samples which are in red and one which is in blue, class 1 and class 2. So obviously, if I'm considering already given there is k is equal to 3, so if I'm going with three nearest neighbors, in the three nearest neighbors are two neighbors who belong to class 1 and one neighbor who belong to class 2. So this particular unknown sample, he will be classified. Now this particular unknown sample, yellow one that you are seeing, he will be classified into class 2. Okay. Now next come to this k is equal to 5. So when I look at the k is equal to 5, here again I have, I need to consider totally 5 nearest neighbors. For this 5 nearest neighbors, I have 3 blue samples and 2 red samples. So if I look at majority voting for the 5 neighbors, the yellow sample can be classified into class 1, that is your blue, because the majority voting supports to the class 1. Now, what are the four things that you need to consider when you are going for KNN algorithm? For any sort of machine learning algorithm, your data processing is obviously needed. And how do you handle the noise? That is another important factor that you need to look at. And then comes the parameter selection. In our case, what is the parameter that we are choosy about? We are choosy about the K, the value of K. And then feature selection and scaling. So feature engineering is another aspect of your machine learning algorithms where you have different kinds of selection techniques, and how do I scale the features. So that has to be done priorly. Curse of dimensionality, I already told you, KNN suits well when your data is very large, but the number of dimensions it expects to be limited. So you cannot have high dimensional data. So you have this curse of dimensionality for KNN. So we better go with a large data set may be accepted, but with limited number of features or dimensions. Now, as I told you, one parameter selection, that is K, is very important. If here what happens is, the more number of the larger the values of K, what happens? If you say I try to have my K equal to your the number of n, the number of data points in that. So if your K is equal to n, so depending upon the majority voting, if you try to fit in whatever is the highest number of class labels you have in your data set, you just take that particular label. And if you have smaller values, that will be affected by the noise, and your separation of classes will not be good. I'll show you one example. So this is a typical yeah, this, I think this would be better first. So here, if you look, if I just took K as 1, so that's a very small value of K. So here what happens if I try to take a small value of K, if you look at this, I have two class labels, a red one and a blue one. Let's say I have given the red process as class 1 and blue as class 2. So now what happens when I try to apply my KNN algorithm with K as 1, you can see if the surface is trying to overfit the blue one which is there among the red one. You have a curve here. If you can see, you you have a curve here. So here, rather than having a smooth surface, you are trying to overfit. Actually, this is supposed to be a noise in your data set, but rather than you are trying to classify your noise also, and then you are trying to overfit it into the correct label, which is wrong. So this is what is called as overfitting data. Now this red one, which has come into this blue one, here also you have a curve that you can see. So having your k value less than 1, that will lead to something called as overfitting of your data, which is not appreciable. This smooth curve is something which is appreciable. K is equal to 5. How do I choose the value of K? This parameter selection is what is very important in your K. Eventually I'll show you how do you choose the value of K. We make use of cross validation in choosing the value of K. But this smooth curve that you are seeing here, this is what is an acceptable curve for your KNN, and in which the blue value, the blue class label that you can see here among all the red, this particular one is something which is misclassified, and you can consider it to be noise and can be removed. Likewise, I have a red one here among all the blue labels. This can also be removed considering it as noise. Now let's say I take a k value which is equal to the n. N is the number of data samples in your data set. Okay. If suppose I am dealing with 10 data tuples or 10 data samples, and I say k is equal to 10, what happens? Out of 10, whatever is your majority, because it goes by majority voting. I am saying k is n. So all are my n nearest neighbors. So if n nearest neighbors I have, among that n in the majority voting, whichever class label is having more number of, yes or no. I am saying yes or no, it could be any class label. The class label that is with the highest value, that will be coming into, that will be the value that is taken over by your test data set, which is not acceptable. So this is what is called as your underfitting. So these are the problems that you come across with your parameter selection of K. You may overfit or you may underfit. How do I decide upon the K value? That we will talk. What would be the failure cases of your K nearest neighbor? This is one example. Now I am trying to, here if you can see in this circle, I have one data sample which I am trying to classify. This data sample seems to be equally at the same distance from your the red samples here, the blue samples here, all the data samples that I have been which has been classified. So if I try, it is at an equidistance to all these labels. So it's very difficult for me to judge and decide how do I into which particular thing I need to fit in. Where you have infinity, very far away points you have for this test data set. This is one failure case. This is a cluster of data sets which have been organized very randomly in a cluster forest. Here, if I take some data, and if you are trying to classify them, it becomes very difficult classifying in this particular cluster, because inside this cluster the data point will seem to be close to every other class label, and it becomes very difficult for us to classify. Now, how do I come across this one? I go with what is called as cross validation. So, what do I do in this cross validation? There is another thing, another you can say limitation or a challenge that we have. You are saying when you are looking at your KNN. Let me show you one program. Okay. If you look at this, I'm just trying to load ID's data set. ID's data set, all of you must be maybe you're familiar. If not, I just give a small introduction to this data set. This is actually from a flowers family. I have a one data set which is called as IDs. There are three different classes that they have been classified into, that is versicolor, setosa, and virginica. When a botanist is asked to classify this, given these flowers, they all belong to one family, and in that one family, they are classified on these three things: versicolor, setosa, and virginica. So, when a botanist is asked to classify them, these flowers into these three class labels, um, what happened, I mean, the things, the attributes or the dimensions or the features that a botanist will consider are these four, which is your petal length, petal width, sepal length, and sepal width. So if I know the flower sepal width and sepal length, petal width and petal length, based on that, will be able to classify into setosa, versicolor, or virginica. And then you have a class label given to it. For setosa, you have given it as 0. For versicolor, it is 1, and for virginica, it is your 2. So now, what is that you are doing here? In your SkyKit, data sets that you have, let me run this. Okay, in your SkyKit data sets that you have, already have some toy data sets which are available inbuilt. So one of the toy data set that we have is ID's data set. So ID's data set is now, you take ID's data set here, 1 second. And what is the internal arrangement of your ID's data set? It is in the form of bunch. Bunch is something called as your dictionary style. So how is your ID's data set arranged? Like bunch A is equal to 1, comma B is equal to 2, X is equal to bunch of. So when I say X of B, it is going to give me the value of 2. So when I say X of sepal width or sepal length, we are going to get the value. So internally, my ID's data set is what is the data type of your ID's data type? It could be an array, it could be a stack, or it could be a queue. Likewise, what is the data type of my ID's data set? The data type of your ID's data set is bunch, and bunch is like a dictionary one. Now, if I want to print the first 5 values of your data set, I just said print IDs dot data. Those who are already familiar with Python, I think this would be a very easy thing for you. :5. It is going to come out with all the 5 different values, and then you are just trying to print the type of X. So it is saying your data set is stored in NumPy arrays. Okay. Now, what are the feature names that you have? Print IDs dot feature name. I have sepal length, sepal width, petal length, and petal width. And then IEE's target. What are the target values that you have? So the target values are 0, 1, and 2. So for few values, it is just printing that. What are the target names? The target names are Setosa, versicolor, and Virginica, where Setosa is designated 0, and I mean the label 0, versicolor as 1, and Virginica as 2. Now, how many how many instances are there, and how many columns are you considering for the classification? That is bought by data.shape, iris.data.shape. So I have totally 150 rows, and then when I say data.shape, I am considering four values: sepal length, sepal width, petal length, and petal width. So that is what here. So 150 instances I am taking, and then each instance, just I am telling you here, this is a homogeneous kind of data, or a very stable, not stable exactly. I mean, all the data sets are the data samples that you balance data set, I can say, because each data or each class label that you have, Setosa, Virginica, and Versicolor. For each of the class label, I have 50 instances. So one of the first one is 50, second is 50, the third one is also 50. So totally I have 150 instances of each type. So that is why it's a balanced data set. Then I'm trying to print here. Yeah. Now here, what is that I'm doing is from sklearn model, you will try to import the train test split. This is very, 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 very important. How am I doing this train test split? So I take all the class labels. I have 150 tuples, right? My data set is having totally 150 samples in it. So what I do is, out of this 150, I'm trying to go for training data. I'm taking 80% of training data, and 20% is my test data. So if 80% is your training data, so 80 into 15, that's what you do. 80 by 100 into 150, which comes to 120. And then the remaining 20% data is your 30. Okay, so 20 by 100 into 150, that's what you're looking at. So now, how do I do this splitting? I say X train X test, Y train Y test is equal to. I have one method, a call, a function, which is train underscore test underscore split, where I'm passing the entire X. X is containing all the training data set. Y is your test data set. What is your test size? The test size I mentioned as 0.2, that is 20%. Okay, and the random state is 4, which will, if you are assigning a value of 4, that means each time it is going to consider the same data set for your classification. Okay, now in this case, X train will contain that 120 tuples, sepal width, sepal length, petal width, and petal length, and X underscore test will contain that respective 120 tuples class labels. Y underscore train will contain those 30 tables, 30 tuples which are to be classified, and Y underscore test will have the class label of those 30 instances. Okay. So now here, if you can see X underscore train shape, you have 120 comma 4. Similarly, sorry. So X underscore train will have the four variables, and Y underscore train will have the output for that training thing. And similarly, X underscore test, the 30 tuples, and Y underscore test will have the values for that particular 30 tuples. So you can see here 124, X underscore will have 120 and those four values, and Y underscore train will have those 120 outputs, and then X underscore 30 will have the remaining 30 tuples which is being used for testing, and then Y underscore test is the final output label for those 30 tuples. Now this is one test, one value that I have just taken, X underscore train of 0. So when I take X underscore train of 0, it is the values of sepal length, sepal width, petal length, and petal width is given as 5.4, 3, 4.5, 1.5. So these are the values. Okay. Now, what is the label? What is the output label for this? Print Y underscore train of 0. The label is 1. 1 means Setosa is 0, versicolor is 1, Virginica is 2. So 1 here indicates versicolor. So this would be a versicolor. On the similar ground, I have taken another test sample. So this is from the training sample I have picked up. Likewise, I have picked up one from the test sample, x underscore test of 0 and y underscore test of 0. So I have, when I say x underscore test of 0, I have all the values here, 6.4, 2.8, 5.6 and 2.1. And with respect to that, y underscore test of 0, you have the corresponding label, which is Virginica. Then you are trying to print the shape. Shape is just going to tell you how many tuples are there in that particular training data set or your test data set. Now, what is that I'm doing? Sklearn kit is one important in your PyTorch or your Python, which is given, where you have almost all the machine learning algorithms which are internally implemented. So in the Sklearn kit, I already have k neighbors classifier, which implements k nearest neighbor. I'm just importing the k neighbors classifier here, and then I'm mentioning the k range. I'm trying to take the k value right from 1 to 26. That's a huge value. So what I do is for k being 1, k being 2, k being 3, I'm trying to apply my k nearest neighbor classifier. Now, your model, when you're using this model, my model will try to find out nearest neighbors, and your k value is also decided, right? So when finding the nearest neighbors is your NN that you are trying to apply here. Now, knn dot fit x comma x underscore train comma y underscore train. So here I am sending the training data. So I'm just trying, when I say knn dot fit, you are trying to come up with your, you are trying to fit your model for your training data. So once I have fit the model for my training data, now I take this model knn and then knn dot predict. I apply the that on your x test. So on your test sample, I am applying. So when I apply on the test sample, I get, see, I already know y underscore test, but I'm not making use of y underscore test. I try to give the the test data as a sample, and then I try to predict the value. Now I will compare y predict with your y test. They should be same. How many y predicts and y tests are same? That is what you are predicting here accuracy. That is how I try to predict the accuracy, and then I calculate the scores of k. And then scores of k, that is the accuracy. So I'm each for each k value, I am maintaining one array. Scores of k is containing the accuracy for k is equal to 1, k is equal to 2, k is equal to 3, like that for until, because you have mentioned k in the range of 1 to 26. So here scores of k here until 26. I have all the values of predicted accuracies for k value being 1 to 26. So now I try to take that one, and then I'm just printing here. If you can see, you can print. You can also likewise come with a maybe a curve, a bell curve, using some matplotlib or Seaborn. Use one visualization technique and try to draw this, and then find out here. For example, I have used matplotlib. I took the k values onto your x-axis, and on the y-axis I have all the testing accuracies. So I just plotted it using your matplotlib, and I can see when my probably when my k value is somewhere near 3, the accuracy is 96.5, and this 96.5 accuracy continued until 20. Until your k value is 20, it was 96 or almost nearly 97. So it was on 97 till then, and later it came down, and again it picked up to 97. So I can say with k is equal to 3, I have the maximum accuracy 97, which is just going, which is significantly stable enough for a long time. So I can fix my k value somewhere around 3 or 4. So this is how you do it. Now, for x underscore new, whatever data set that you have given, I'm trying, how is my model doing, whether it is doing good or not. Here, already we have taken one data set for which I said we will, this is used for testing purpose. If you can see, 5.4, 3, 4.5, 1.5, or you can use the 6.4, 2.8, because the class labels are already known to you. You use any one of this data set, which I have used 6.4, that particular thing I have used here under x underscore new. I have passed two samples, and then I just fit the I just try to fit my use my model onto these two samples, and then I am predicting the value of 0 and 1. wherein the accuracy is correct. I mean, it came correct. Now here, what is the disadvantage with this one? I mean, I told you, how do I predict the k value? You have predicted your k value, very good. Here already I have predicted my k value, but this k value may not be valid. Why? Because this is part of your data that is already available to you. You have the test data, and you have predicted the accuracy only just based on your test data. That 20% sample that you are taking, I am coming out with an accuracy from that 20%, right? So now if I get an unknown sample, I don't know whether this accuracy from that 20% of data I have brought out, I mean taking the 20% of data with which I have predicted the accuracy, this accuracy will be the same for an unknown sample. This is the reason that we go for your K cross validation. So now what do I do in K cross validation is I just leave the you have 80% and 20%, that is how you have considered in your KNN. Now here what I do is I do 60 and 20. I take 60% training data set and 20% test data set, which is totally together 80%, and the remaining 20% is something which is unknown sample. So for the unknown sample, whatever accuracy I get, I take that particular thing. So now taking this 60% data, I mean, under that 80, if you can see, I have split my 60% into four trains, training data, and training data, and one test data. So this totally the 80% data set that you have, that 80% data set you have split into totally five parts, in which four parts are your training data set and one part is your test data set. Now what I do is I apply your same algorithm, your KNN algorithm for the first two, taking the first four portions that will be used for training purpose. Whatever model I build, make use of use that model for your test data with various values of k. Likewise, I again make the test data which was part of your training in the iteration, that will become sorry, which was there in your iteration one, the test data, that will be part of your training in the iteration 2, and the other block here, if you can see the other block, this is considered as your test data. In the third iteration, I am making my test data which was there in iteration 2 as part of your training data, and your third one will be your test data. Right, so this likewise all the 5 over 4 iterations that I have, each iteration your test data I am just making part of the training data. Now what is that exactly you are trying to do? This example will give you a clarity. Now initially I take my k value as 1. Okay, so I don't look at the 20% of data, I just put it aside totally. I just take that 80% of your data, and that 80% I'm splitting into 60 and 20. 60% of data is used for training, and then 20% of the data is used for cross validation testing. Okay, so if you look at this, I have divided into four. Sorry. I have divided that into four. So I have like D1, D2, D3. I use that for training. I build a model. On that model, I use my cross validation, the remaining 20 portion of the data, to find the accuracy. Okay. Likewise, again K is 1. Now D4, which was part of your test data of cross validation, is made part of your training data, and I brought out D3. Likewise, I will bring in D2 inside. I'll bring in D1 inside. So I'm just changing my training data and my test data. So for each of the test data, what is your accuracy? So like suppose when k is equal to 1 and D4 was your training and D1, D2 as part of your training data, I got some accuracy A4. Then the other one I got accuracy A3. What I do is for k is equal to 1, I average out A1, A2, A3, A4, and that is the final accuracy for your for k is equal to 1 with 80% data considered into training and testing. So I for k is equal to 1, whatever this you got average value that you have noted down. Likewise I do for k is equal to 2. Likewise I do for k is equal to 3 and k is equal to 4. And then out of all this, I try to choose the best K. Whatever is the best K, you choose. Now for this best K, what I do is, now the remaining 20 data that you have, I have totally 100. In 100, I have taken 80. Out of 80, I have taken 60% for training, 20% for cross validation. Now the remaining 20 that you have, I have calculated my K here. Now that 20% data I didn't touch. I didn't make use of it anywhere in your accuracy calculation or in determining your K. Now I make use of that unknown 20% data to check whether for the given K that I have calculated from the cross validation is giving me the same accuracy as it has given here. So I try to predict for that, and then I freeze that particular accuracy. That accuracy now is believed to be giving the best accuracy for given any kind of unknown data set. Okay, with the same kind of, for any unknown samples, it comes out with the same kind of accuracy. Now, uh, here the challenge is how many, if you can see, how many how many folds of validation that I have done. Here you can see I have done 4 folds of validation. This is called as K fold, K dash fold cross validation. So the cross validation is done with K dash fold, and the number of folds that you have is 4 here. How many folds is acceptable or good enough? Generally, they say 10K folds like that is one optimal fold value that you can take. So K folds 10 can be taken, and taking 10K fold values, determine your K and then determine your accuracy, and then you can test that with your test data set. Now, if you look at this, okay, the same IEEE data set, everything is the same. Just here, if you can look at it, I just took the same data, the set size as 20. I made part of what is called as your CV. Here, I have split your training data set into training data set and your cross-validated data set. So, where I said 20% of this is used, 60% for your training, 20% for your cross-validation, and the remaining 20% is for identify for looking at your test data set. Otherwise, it is very easy enough. The lucky we are that with your Python, you have all your algorithms which are already implemented. So I just need to take the from the scalar which particular method I need to take. I just need to take that and I need to work on it. That's it. The next algorithm is also a classification algorithm, which is called as naive-based classification. This the naive-based is totally built on what is called the prerequisite knowledge for your naive-based is probabilities, in which you have your conditional probability. Many of you are already aware of what is probability. So it is either a 0 or 1, depending upon your outcome. An event I'm just quickly moving through the slides because probability is one topic which you all are familiar with. So E is an event that the outcome of some experiment. It can lead to either 1 or 0 or some observation, yes or no, something like that. So these are the basic things. You denote your event with an E, a simple event. So all the test samples, all the different kinds of simple events that you do in that particular sample space, that is denoted by your S. One example here, when I'm looking at an odd number A1, 3, 5, that particular set is having the odd number of things, and B where I'm saying a number greater than 2. So you have 3, 5, 4, 6, all which are into your P. Okay. So now what is the probability? How do you do your probability? The number of times your A occurs divided by the total number of how many times you're performing that experiment. This you all know. Always your probability will be either 0 or 1. Occurs or not occurs, or if it occurs, it is one output or the other output. Okay. So one conditional probability, this is very important because your naive base is totally based on your conditional probability. How do I write a conditional probability? Occurrence of some occurrence of one particular probability based on some condition. Given a condition, the probability that A will definitely occur, given that event B has occurred. Okay, so this is called your conditional probability of A. So I'm looking at the probability of occurring of A given B has already occurred. So the condition here is B has occurred. Okay, so B has occurred. Based on that particular condition, I am trying to define your conditional probability. Now, for example, if you look at this, D1 plus D2 is less than or equal to 5. There are two dice which I'm just throwing. I built a table out of this and I'm saying D1 plus D2 is less than or equal to 5. So when I look at this, you have this whole this kind of graph that has come. I mean, this kind of types which has come up. The total number of values where D1 plus D2 is less than or equal to 5, I have totally 10. The number of occurrences, if you see, 36. I have totally 36 occurrences. And so the probability for D1 plus D2 less than or equal to 5 is 10 by 36. Now I say this has occurred. This has occurred. Okay. Now I say I based it on one condition, and the condition that I am giving here is D1 is equal to 2. So I just want D1 to be 2. So with D1 being 2 and D1 plus D2 being less than or equal to 5, what are the chances? 3, 4, 5. With D1 being 2, if you look at this, this is the only thing. Where D1 is 2 and D1, D2 is less than or equal to 5. So this particular row that you can see here, 3, 4, 5. This particular row is the one. So my conditional probability here says that tell me the probability of occurring of D1 plus D2 less than or equal to 5 is 10. But based on the condition that D1 is equal to 2, then it became 3. So 3 by 10. This was totally D1 plus D2 less than 5 was 10. And then based on the condition D1 is equal to 2, it became 3. So 3 by 10. Now this conditional probability plays a very important role. We will see eventually what is the role that it is playing. We have another important thing, that is your independent events that are occurring and mutually exclusive events in probabilities. If two events A and B, well, probability of A or B, and it leads only to P of A or PB of A, occurrence of BA based on some condition B has occurred, it leads to only probability of B. So they are totally independent and not dependent. Mutually exclusive events at one point of time, I can have only one thing. Like if you look at the cards, if I have a king of some particular shape, I cannot have the same king of different color in that. So if a card is a king at that point, it is a king. It cannot be a queen, right? So this is what these are what are your mutually exclusive events. This all of you are familiar. Probability A or B is equal to probability of A plus probability of B minus A and B. Now I'll just look into the Bayes theorem. Now this is very important. How do we classify your how Bayes theorem works? Bayes theorem basically works on your conditional probabilities. It says P, the hypothesis, the occurrence of X based on the hypothesis. This particular, sorry, this particular part is what is called as your posterior probability. So, Bayes theorem is based, all of you must have learned or many of you must have worked some problems on this. Probability of occurrence of X based on some hypothesis, your posterior probability. P of X that we see, it is the evidence, that is a class label which is known. And then you have something called as prior probability and likelihood. So this probability of hypothesis based on X is your likelihood. And then P of X, P of H, the P of H that you are taking here is your prior probability. So this is the thing. These are the things that you have. Now, what is it that you are looking at? Now, let us take one example and go. Let us dive deep into this. I'll take this example itself. This is one famous example from your Canva. Okay, I have a student age, income, and then I have a student credit rating. I have some person's age, income, and I'm checking in whether he's a student or not. His credit rating you are looking at, and then you are trying to classify, given these details, You are trying to classify whether he's going to buy a computer or not. So the class label here is whether he will buy a computer, yes or no. This is what you are looking at. Now, if you look at this, the totally 14 tuples that I have. This sample is having totally here. If you count, you have totally 14 samples, and then for each one I have different categories. For age, I have less than or equal to 30, 31 to 40, greater than 40. For income, high, low, medium. For student, you have two labels, yes or no. Credit rating, you have fair, excellent, and then for computer, whether he buy computer, you have yes or no. So these are the things that you have. Now, given this, I want you some person X. His age is given, age less than or equal to 30. His income is given, that is medium, and then he's a student, and his credit rating is fair. Now, based on this particular data, can you please, you classify and say whether he will buy a computer, yes or no. So this is what you are looking at. Now, how do I do this? This is where your conditional probability or your all the probability examples come into picture. So first, now the number, how many buys computer is equal to yes. First of all, let us look at the probabilities of the conditions. That is yes or no. The number of people who are buying the computer, how many yes I have and how many no I have. I have totally 9 yes. So it is 9 by 14. And the probability that he is not going to buy a computer, you have 5, 5 by 14. Now I will try to compute the conditional probabilities for each of the x value. The first x value that you have is age less than or equal to 30. I would like to say the probability that he is going to buy a computer is yes, based on the condition his age is less than or equal to 30. So the conditional probability I am making use of. So here what happens when you are trying to use this, by how many, by now for less than or equal to 30, when you look at this age less than or equal to 30, for how many less than or equal to 30 you have buys computer yes and buys computer no. So if you look at the age, the first one I have no, the second one also I have no. Then here I think third, fourth, five, sixth, seventh one, eighth one I have no. Ninth one I have one yes. 10, 11, 12, 13. Yeah. 11th one again I have yes. So for less than or equal to 30, how many values is buys computer yes? So for less than or equal to 30, Vice computer is yes is totally the number of values I have is 2. The total number of Vice computer S is 9. Out of 9, less than or equal to 30, which is leading to yes is 2. So the probability of age is less than or equal to 30, and he is going to buy a computer which is yes. The value will be 2 by 9. The number of tuples which are taking the value yes is 9. Out of that 9, I have totally 2 people who are age less than or equal to 30. Similarly, age less than or equal to 30, how many of them are not going to buy the computer? Buys computer is equal to no. So the number of tuples out of 14, the class label that you have is 14. Out of that 14, I have totally 9 yes and 5 no. In that 5 no, whose age is less than or equal to 30, the number of no's that you have is 3. So here, for probability age less than or equal to 30, buys computer is equal to no, you have 3 by 5. Okay, so this the first one is one probability, conditional probability we have calculated. The other conditional probability that we have calculated. This next one is income. So his income is medium. So given that his income is medium and he is going to buy a computer, yes, and he is not going to buy a computer. This on the similar level, the similar way that we have done for your age, we will be doing for your income also. So when I do that for my income, you have some values that have come up. Now, he is a student, and how many tuples having student is equal to yes, and they have buys computer is equal to yes, out of the total 9 yes. So if you look here, student no, 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 like 1, 2, 3, 4, fifth one is a yes, and the corresponding buys computer is also yes. Sixth one is yes, but the corresponding buys computer is a no. So you check like this, how many yes I have, and for that yes, how many of them of them are going to buy a computer. Take a count of that, right? So when I take a count of that, out of total 9 yeses, there are 6 students who are going to buy computers. So 6 by 9. Similarly, for a student who is not going to buy a computer is out of 5, it is 1, so 1 by 5. In the similar way, you look at for credit rating being fair, how many of them buys computer and how many of them are not buying computer. I calculate the conditional probability for that also. So once I do this, now how am I going to do the final classification? The final classification is based on your this particular thing, that is your Bayes theorem, where you take posterior probability, you try to take the prior probability, multiply with your hypothesis divided by your evidence. So I do that. I take the posterior probability. Here I take the posterior probability, which is P based on the condition Y's computer is equal to S for X. X could be what? Your X could be age less than or equal to 30. X could be income is equal to medium. Student is equal to yes. Credit rating is equal to fair. So any of these. I take all these values for which I have my own, your own, the calculations that you have done, multiply all of them. Similarly, Bayes computer is equal to no, for which you have X different values. Calculate all of them and check which values the also you look at the multiply that with your yes as well as with your no, and see which value is the highest. If I look at this, with no I have 0.007 and with yes I have 0.028. So the highest value is your yes. So I finally say X, X whose age is some less than or equal to 30, income is medium, student yes, and credit rating is fair. I will say that he will belong to a class label where he say yes, that is he is going to buy a computer. So this is one another algorithm, that is naive Bayes algorithm. I'll just show you the implementation of this one. It is almost similar to your KNN. Only thing is, if you look at this, I just make from sklearn. This is a comparison collab file that I made to compare your SVM and what do you call your naive Bayes as well as KNN. But here I'm just showing your naive Bayes. So if you look at this, I made use of from the sklearn. I have made use of Gaussian naive Bayes is the one which is the standard generally we make use of. So you import the Gaussian naive Bayes, and I just took that, wherein the same thing you are trying to take your split test train, and then you are trying to calculate the accuracy, and then you try to print it. So accuracy for your training set as well as accuracy for your test set. So if training set is giving 86%, for your test set it is giving 67. I don't think you will adopt this naive Bayes for your IEEE classification. This particular collab file was used for IEEE data set for all the three classifications: SVM, KNN, and naive Bayes. Okay, so it was used for this, and then it is found that SVM also does a good job compared to SVM. Naive Bayes is worse, and then the best one is your KNN that works for your IEEE data set. The other kind of things that you have is your decision trees, which I'm not going to talk about. I'll just show you. For the same example which you have seen, naive Bayes, I can make use of your decision tree model or algorithm apply here, and you come up with a tree structure like this, or if else rules in case of your decision tree. This is one more classification and a famous algorithm that we have. The next one, I'll just give a quick glance of this. Quick flow of this, and then we'll conclude. Clustering. We have seen supervised algorithms till now, and then you have one unsupervised algorithm which is clustering. So Clustering is one famous algorithm which is used mostly with your text documents. So if you are working on text mining, text classification, information retrieval, document summarization, clustering is one good approach that you can make use of. This is an unsupervised algorithm where I don't know anything about my data set or my data labels. To what am I supposed to classify that? When I look at the clustering, I have various algorithms. I have a partitional approach, and the other one is hierarchical clustering. For partitioning clustering, I have three different algorithms, that is k-means, k-modes, and k-medoids. For hierarchical clustering, I have agglomerative clustering and divisive clustering. So these are the different kinds of clustering you have. I would just like to give a glance of k-means algorithm here. So what do I do in k-means? I randomly select the value of k. K could be 3 or 4 or 2. And then each time I try to divide the data set. With this example, if you see A1, A2, A3, B1, B2, B3, C1 and C2. What I do is A1 is, suppose I say k is equal to 3. I choose a seed point. Let us say the seed point for the first cluster is A1. For the second cluster is B1. For the third cluster is C1. And then I try to come up with a distance table. This is your Manhattan distance. As I spoke about this, like in KNN, here I have a Manhattan distance modulus of x1 minus x2 plus y1 minus y2 modulus. You are taking Manhattan distance. So I'm trying to calculate the dissimilarity matrix here, not the similarity matrix. Please mind you. So when I do this, I try to group them into clusters. Okay. So whichever is nearer to whichever centroid, I call them as the seed points. I will call them as centroids. To whichever centroid is that particular points that you have considered, they are close enough. I put them into one cluster. So I try to put them into clusters like this: cluster 1, cluster 2, cluster 3. Later, I will try to calculate the average of these values that you have here. I try figure out one average point. For this average point, again I recalculate your dissimilarity matrix and I do the clustering part. So this is how your k-means algorithm works. Now, on the similar grounds, you have your k-medoids and k-modes also working. Agglomerative clustering, where we have a top-down approach and a bottom approach of your agglomerative clustering, where you can use a hierarchical clustering in any one of these, either of these approaches, agglomerative or divisive approaches. So this is just an overview of your supervised and unsupervised machine learning algorithms. Most of the algorithms have already been inbuilt in your Python sklearn kit. You have almost all the implementations. You just need to choose that particular library and then make use of it, and then look at the how the analyze the data and see how your output is coming, or you can make your predictions. Okay. Any doubts?
Any doubts from the participants?
Okay then. Thank you for the opportunity. Thank you for this session. Thanks a lot.
Yes, sir.
On behalf of child, co-child, programming child, coordinators, co-coordinators, and participants, and on my behalf, convey my deep regards and hearty thanks on today's session speaker, Dr. N. Sandhya ma'am. Thank you, ma'am, for the wonderful session about the various machine learning algorithms, supervised and Supervised learnings, various algorithm functions used for development of algorithms and KNN algorithms along with good examples, ma'am. I hope this session had created sufficient interest among participants in the field of machine learning. Thank you, ma'am.
Hello. 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 సార్ 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 అయ్యో రమ్మని చెప్పండి సార్ మేడం వస్తున్నారండి పంపిస్తాను మేడం ఒకసారి కాల్ చేయండి మేడం మేడం నాకు చేశారు వస్తున్నా అని మేడం చెప్పాను ఆల్రెడీ ఒకసారి కాల్ చేయండి సార్ వస్తున్నట్టున్నారు ఎవరో సార్ని తీసుకొస్తున్నా అన్నారు
చెక్ పవన్ చెక్ ఇది ఒకటి ఆపితే ఒకటి చెక్ 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 చెక్
ఒకటి ఉంచు అవతల ఉంచు ఆఫ్ అయింది ఇంకోటి కూడా ఒకటి ఉంచు ఒకటి ఆఫ్ చేయి ఆన్లో ఒక రెండు ఆఫ్లో ఉన్నాయి